Let's learn in this video some tips to appear practical examination paper and some tips to take care while performing the practicals, especially during the examination. So let's cover about practicals, the manipulation, measurements and observations, presentation of data, that is the readings taken and observation, analysis, conclusion and evaluation of the practical performed. So let's start with some points to cover in the manipulation, measurement and observations. The first one is we should be knowing to set up the apparatus correctly. Also, use the apparatus correctly to collect an appropriate quantity of the data and observations, or in the other words, we should be able to use apparatus correctly to take the accurate readings. Also, make accurate measurements using pipette, burettes, measuring cylinders, thermometers and other common laboratory apparatus. For example, if this is the burette suppose, then the lower meniscus has to be read. So lower meniscus reads 23.45 centimeter cube. Now we should not mistake it by reading it as 24.55. This is 23.45 and we have written 45 because it is in between the two readings of 4 and 5. Now we should also take care that our eye level should be exactly in front of this lower meniscus. So when we are observing the readings, our eye should be at the level of the burette reading to read it correctly. Now let's take an example of correct measurements. Here is one example. It says the burette reading should be to the nearest 0.05 centimeter cube. In the other words, it is half the way between two of the smallest divisions. Now, what are the two of the smallest division? We can read 0.1 is the smallest division. So, half of it is 0.05. So, we should be able to read 0.05 centimeter cube volume in a burette, as we have already seen in that diagram which was for the burette reading. And also the average burette reading which we take, that is we take various accurate burette readings and then we need to take the averages of those accurate burette readings to be considered for further calculation. Those average burette readings should end in 0.00 centimeter cube or 0.05 centimeter cube. That is, the average burette reading should be considered to 2 decimal places. Now, when carrying out the titration, we should repeat the test until we have 2 titers that are within 0.1 centimeter cube. Means that the 2 burette readings during the titration should not have a very big difference. It should not be far off than 0.1 centimeter cube. Say for example, our one of the reading is 24.5 centimeter cube. Then our other reading should not be much away than 24.00 or 25.00 centimeter cube. So that's what we meant, that our 2 titers to be considered should not have a difference of more than 0.1 centimeter cube. And ideally, we should be aiming for 2 concordant titers within the same value. That is, 2 continuous titers should have a similar value, same value, to be considered the perfect readings. Now let us consider a tip for performing the burette readings. Here, say we have got an approximate endpoint of our first reading to 22.60. We can call this as a rough titer also. If it is 22.60 centimeter cube, then for the further accurate titrations which we are going to consider, we can run 20 centimeter cube of the solution from burette directly into our conical flask, swirling the mixture before adding a few drops at a time. Means that if our reading is approximately 22.6, we can run 20 centimeter cube directly and then add drop wise till we get the perfect color change. This is going to save our time for the practicals. Yes, we should consider one more point here which is very important, that do not add more than 2 or 3 drops of indicator unless and until it is instructed in the question or it is instructed by the supervisor. Now let's consider one more type of experiment, that is kinetics experiment, or you can call it as a rate of reaction experiment. Suppose if we are performing a rate of reaction experiment, then if we are adding a quantity of one of the reagent to another, mixing, and then we are supposed to measure the time taken for the reaction to occur, then we should make sure that start the stopwatch at the same time every experiment of the kinetics. That is, if we are starting the stopwatch halfway of adding the reagents, mixing the reagents together, then every time we perform the different reading, we are taking the different reading for kinetics, we should be starting the stopwatch halfway always to get the fair readings every time without error. Now let's consider few errors where students commonly make it. Example, if a procedure says that add a few drops followed by excess of any one of the reagent, but if excess of the reagent is added altogether, that means that there was some observation to be considered for the few drops of the reagent, and then one more new observation to be made when excess reagent was added. So if we add excess reagent altogether before adding few drops, then we are missing some observation which will miss the marks also. Now in kinetics experiment, we always have a sequence of reagents to be added. That is, one after the other, the reagents has to be added in proper sequence. If this sequence is missed or the wrong sequence is followed, then our observation or the reading may go wrong. Now let's consider the presentation of the data and the observation. Presentation of the data in the sense, how are we writing and presenting the readings which we have taken. So it is very important that whatever we have carried out the practical task, the results are recorded systematically and logically, which an examiner or the checker understands it properly. And in most of the practicals like titration and enthalpy, that is, students need to draw their own table for the data. No table, no data is given in the question paper. So drawing a correct table with correct columns, headings and units is very important, as here we have an example. Suppose if we are considering an enthalpy experiment, then we need to note down the temperature. So reading, that is experiment number 1, experiment number 2, each of these experiments should have initial temperature, final temperature and the difference in the temperature with the correct unit. Now you can see that we have also considered unit in the table. So that is the reason that we don't need to write unit in the table. So unit have to be written in the heading of the table. Now suppose if we have kinetics experiment, we are considering some concentration of a solution and we are taking various readings for the time. So we need to divide one column into the various sub-columns, and then at the end there should be a mean of all these tests. So this is how we can present our data in a form of table with columns and sub-columns also. So we should note that the heading in the table have their own units included. So we need to write units in the heading of the table. So therefore, we do not need to record the units for each of the reading or the entry we make in the table. Now, after the readings taken, if we are told to draw a graph in the examination practicals, then there are a number of key features we need to take care while drawing the graph also, because the examiners also look to these points. Now, this includes a title that describes what the graph represents. Both the axes should be labeled, including correct units with the axis labeled. Independent variable plotted on the x-axis and the dependent variable on the y-axis. Now, we should know that what is independent variable and what is dependent variable. Independent variable is the factor which we are changing during the experiment. For example, if we are considering a kinetics experiment and we are changing the concentration of the solution and measuring the time. So in that case, independent variable is the concentration, because that is what we are changing, and what are we measuring is time. So dependent variable is time. So dependent variable is the one which we are measuring and the readings for which we are taking. So independent variable on x-axis and dependent variable, that is measurements, on the y-axis. And while drawing a graph, we should be using a very sharp pencil plotting the points, so that the points plotted is exactly at the point where it should be and there should not be any confusion. While choosing the scale on the graph, it should be a sensible scale, in the sense that scale should at least cover more than half on both the dimension, that is on x-axis also and y-axis also, the grid which is given. The scale chosen should cover more than half the grid, so that our points are plotted correctly and is seen properly, and the line which we are drawing also goes correctly. Drawing a line of best fit is also very important. Here is also where students make a mistake. To choose which line is the best fit is very important. Here we will consider an example of the line of best fit. Next, identifying an anomalous result. Anomalous or outlier result is one which doesn't fit our best fit line. So we can circle our anomalous result to show it that it is an anomaly. Now let's consider a best fit line with an example here. The diagram below gives an example of the best fit line. Now we can see that the points are drawn with a cross. Here dots are not drawn. Why? Because the points drawn in the cross shows very precisely the point which you have drawn. So rather than drawing a points, it is advisable that you draw such crosses with a sharp pencil. Now we can see that our line is passing through the origin and passing exactly through one point only. The other points are above and below the line. But still we consider this line as a best fit line because the line drawn, the line chosen is in between most of the points, or you can say is nearer to most of the points. So this is called the best fit line. Best fit line is not the one which is passing through many points, but it is the line which is nearer to most of the points. In other words, you can say that the points are equidistant from the line with equal numbers. This is called best fit line. Now, presentation of data and observation just doesn't mean that how are you tabulating your readings, but it also depends on the words which we use to express our observations. So, the words we use are also very important. Example, do not use the words such as see-through or transparent for some solutions. We can use the word colorless solution for some observations. While writing the observation, try to be precise as possible about the colors also. For example, a simple word like blue is rarely enough to describe a color change, especially for example, a solution of copper ions are taken and we are adding an aqueous ammonia solution progressively, in the sense a small amount at the starting and then excess. Then how are we going to describe it? What are we going to get is a pale blue precipitates at the starting. So use of word the pale blue precipitates is very important, and then the solution becomes colorless or clear and the color becomes deep blue after adding excess ammonia. So here the use of the word pale blue and deep blue with a clear or colorless solution, here pale blue precipitates, such words are very important and precise to be used. Now in one of the experiment, if gas is given off, then we can't just directly write that the carbon dioxide is evolved. We need to write first observation as the bubbles, or effervescence and then describe further that the bubbles produced were carbon dioxide by some more tests. Another important part of practical examination is analysis, conclusions, and evaluations. In order to draw conclusions and evaluate the procedures you have carried out, we first need to analyze the results of any practicals we have completed and then explain that what they show. And also, before reaching a conclusion, we may need to carry out some calculation. And if this is the case, that is, if the calculation is needed, we need to show some key steps to the calculation. So, directly writing the answer of the calculation will not gain any mark. Showing the calculation is important and then drawing the conclusion from your results from your calculation is important to get full marks for such a procedure. You may also be asked to draw a graph to display your results because this is an excellent way to show the trends or the relation of your results. So in that case, a straight line graph passing through the origin shows a directly proportional result between the dependent and independent variables which we have taken on x-axis and y-axis. Sometimes the graph may be a curve. Then in that case, we may need to measure the gradient of the curve at different points. So in that case, what are we going to do is use large triangles to calculate the gradient at that particular point and then calculate the gradient. This gives us a more accurate calculation for the gradient or the further calculation to be made. Now when it comes to evaluation relies on your ability to think critically about the reliability of the data you have collected and the conclusion drawn. Now what does this mean? That is the readings which we have taken, how reliable they are, and the conclusion which we have drawn, that is directly proportional, or if we find out about the rate, that rate is dependent on the concentration, then how far all that is dependent on each other and how far is that reliable. That is deciding the evaluation of the experiment. Now one of the way to evaluate correctly is to think about the errors that affects our results. So when we evaluate an experiment, we should be able to do some following points, that is suggest an improvements to the procedure. For example, if we want to use a burette pipette in place of measuring cylinder, that is one way of improvement, or repeating the results and then taking an average, that is also another way of improving the results. Compare repeated results to judge their reliability. That is, you can compare your repeated results and check that they are close to each other, then it can be reliable, or you need to repeat it few more times to get the reliable results. Identify any anomalous result on the graph, which we also call it as outlier, and we also need to think about that why the result is anomalous, so what error has occurred in taking that particular reading. Also identify the variable you need to control. Now variable we need to control are the factors which we need to keep same. That is the factor to be kept same. That is, what are the things which we are keeping same during a reaction. Example, in an enthalpy reaction, the temperature has to be kept same if we are taking the initial temperature of the solution. So initial temperature should not vary much, or you can say the volume of the solution has to be kept same every time we take different readings. If we are considering rate of reaction, then the total volume of the solution, the mixture, should remain same. So there are certain factors that has to be kept same. Those are considered as controlled variables. Estimate uncertainty in the measurements. Now what is this? It's like you need to consider the maximum error possible in our readings, and then you may also be asked to calculate the percentage maximum error. Now that also you need to learn that how to calculate the percentage maximum error for any readings which you have taken. And that counts in the least count of the apparatus also. Distinguish between the random and systematic errors. Now what is random and systematic error? Random error is something like which is not in our control, that is while taking the readings, if we have missed some time or we have wrongly read the reading, then it's a random error. But systematic error is the one like in the enthalpy experiment, there is a heat loss to the environment. Now that cannot be controlled. So that's a systematic error which is going to occur. If there is some error in the apparatus measurement, or you can say graduation of that apparatus, that is also a systematic error which cannot be controlled. So we need to distinguish between random and systematic error also before we evaluate an experiment. So these are very few important points we need to consider for the examination of practicals and writing the practical papers. So if you have liked and found this video useful, do add the like, and also if you like, add the comments in the comment box.